So we'll be starting with chapter 1 today. In my opinion, even though chapter 1 is probably the easiest and the smallest to go through, it's one of the most important. Not only with reference to your own papers, but also with reference to science in general, because it has to do with measurement techniques. And measurement techniques are used in experiments. And as you probably know, experiments are the fundamental basis of all science. But besides that, in your paper, you might think that if you skim through this chapter, you'll get through P1. And yes, you will get through P1 because all the MCQs that come from P1 for this chapter are very easy. But when you go to ATP or the practical, whichever one your school gives, that's where you're in trouble. Because if you don't fundamentally understand what measurement techniques are about and why it's important to use appropriate measurement techniques, then you won't be able to solve ATP. You'll have questions that you won't be able to attempt because you think they're out of syllabus when they were actually just from this chapter. So now let's move on to the first concept that we need to understand. That is the concept of a physical quantity. A physical quantity is anything that you can measure, and that means literally anything, like mass, length, speed, time. You can measure all of these things, and therefore all of these things are called physical quantities. Now, in a lot of your books, you might have seen the word derived physical quantities, and maybe your teachers have told you about this too, and base physical quantities. But at this stage in O-level IGCSE, you do not need to know about this. This is not in your syllabus. But it's good if you're really interested, then you can, just read your book. It's a pretty basic concept. But what is in our syllabus are the two types of physical quantities, which is scalars and vectors. So let's start off with scalars because they're relatively easier to understand. Scalars are physical quantities, which means that they can be measured, but they only need a magnitude plus a unit to be defined. Now, what does that mean? You already probably know that a magnitude means how big or how small something is, and a unit is a defined magnitude of a quantity. Defined magnitude, mag, of a physical quantity. Now, what does that mean? Suppose your physical quantity is length, and a unit for length would be meter. Now, you know that meter never changes. It has been defined. It's a defined magnitude for the physical quantity of length. But to put things into a better perspective, let's talk about an example. Let's talk about the physical quantity mass, which is a scalar, by the way. Let's say you went to a shopkeeper and you asked them for a bag of rice. Now, the shopkeeper can't help you unless they know how much rice you want, how much the rice weighs. So you think about it and you say, okay, it should weigh 5. Now, what you've given them is a magnitude, how big it should be. This is a magnitude. But they still can't help you because they don't know if it's 5 grams or if it's 5 kilograms, because both these units are entirely different. So therefore, you give them a unit. You tell them that I want 5 kilograms of rice. And therefore, whenever you define mass, in order to properly define it, you need to give the person a magnitude, and you need to give the person a unit. And that is scalar quantities. Now, vectors are slightly different, but they're not hard to understand either. Vectors are also physical quantities, which means they can be measured. However, in order to define a vector, you need a magnitude, you need a unit, you also need one extra thing, which is direction. Now, for example, you have this box. Now, I come up to you and I say, all right, can you please push this box with a force of 5 newtons? Newtons is the unit of force, by the way. We'll talk about this in the next chapter. But I ask you to push this box with a force of 5 newtons. Now, what you have over here is the magnitude, and you have the unit. But the problem with forces, and force is a vector quantity, by the way, that you don't know where to push the box. You don't know if you need to push it towards the right, towards the left. You don't know if you need to push it down or up. It could be literally anywhere. But the thing is, I want this box to be over here at point B. And I can't just telepathically tell you that. I need to give you the direction. let's use another marker. Yeah, I need to give you the direction alongside the magnitude and the unit in order for you to properly move the box the way I want. So I tell you push the box with a force of 5 newtons towards the right, and then you'll be able to get to point P. So I hope you understand why direction is necessary to define vectors. Alright, so your syllabus also requires you to be able to label these 8 quantities as vectors or scalars. Now, when I say syllabus, I mean the 2022 syllabus for IGCSE and O-levels. So you might not know what some of these terms mean, but that's okay because you'll be studying them in the next chapters. But for now, you need to know that displacement is a vector, distance is a scalar, length is also a scalar, speed is also a scalar, velocity is a vector, time is a scalar, acceleration is a vector, mass is a scalar, and force is a vector. Now, for the people that are preparing in 2023, IGCSE or O-levels, you have these quantities added to your syllabus. You need to know whether momentum, electric field strength, and gravitational field strength are vectors or scalars. And the easy thing to remember is that they're all vectors. Why? We'll explain that in the coming chapters. Let's start with scalar addition, which is fairly simple because it's literally just simple addition. That's because direction is not involved. Now, let's say you have a stone of 5 grams, let's say 5 kg, and then you have another stone of 5 kg, and you want to know that if you put these stones together, how much mass would you have? You simply just add 5 plus 5, which is 10 kg. So vector addition is slightly different, and for the sake of this example, I will be using forces and vectors. So whenever I mention forces, I just mean vectors. In the first scenario, you have both your forces acting in the same direction. You have this box, and there's 2 people pulling it in the right direction with a force of 5 newtons. So what will the net force on the box be? And mind you, net force is not the same as total force. I'll go into detail about this in the next chapter, but for now, you just need to know this word, net force. Alright, so the net force will be 5 plus 5 is equals to 10. Because they're in the same direction, you just simply add them together to get 10 newtons, which is going to be your net force. In this example, however, when both the forces are in the opposite directions, you have this box and one person is pulling it to the left with 5 newtons and the other person is pulling it to the right with 10 newtons. What will the total force be? Net force be, and in what direction will it be? You'll subtract the bigger value by the smaller one, which will give you 5 newtons. Now you have a net force of 5 newtons, but in what direction? The direction will always be that of the bigger force. If one person is pulling it harder, obviously the box will move in their direction. So if this was right, the box will be moving with 5 Newton force in the right direction. So in the third scenario, you do have 2 forces acting on one box, but they're not in the same direction and they're not in the opposite direction either. One might be towards the top, one might be towards the right. So what you do in this scenario is called graphical addition. The first step would be to make a scale. Why? Because you need to redraw these arrows on your paper. These arrows represent force and you need to redraw them with the scale. An appropriate scale here would be 1 centimeter is equals to 1 Newton, and make sure that your scale is appropriate because you do get marks for that. So if 1 centimeter is 1 Newton, 5 Newtons would be 5 centimeter, and 7 Newtons would be 7 centimeter. Now once you redraw your arrows like this, and make sure that your arrows are very, very accurate, because if you don't make this exactly 5 centimeters and if you don't make this exactly 7 centimeters with your scale, you will not get the correct answer for net force acting on the box. Once you've done this, and you've also made sure that the angle between the force is correct, right now the angle is 90 degrees, because this was mentioned in the question. Sometimes the question says that the angle will be 60 degrees, sometimes it is 30 degrees. Make sure whatever angle it is, you use a protractor and you make sure that the angle is what they've mentioned in the question. The length should be correct and the angle should also be correct. Once you've done with that, you will come to step, I think this is 2, yes. You'll redraw both these arrows. You had one arrow for 17 here. You'll draw one here too, which is parallel to the other arrow. You'll draw one over here and you'll draw one that is parallel to this arrow over here. Now make sure that the new blue arrows that you've drawn start from the tip and end on the other tip. They should be the same length, they should be parallel, they should have the same angle between them as this one did. And once you've done that, and please make sure that you label them. Labeling is very important. You might get your marks cut if you don't label them. Then you'll draw the purple arrow. The purple arrow essentially is the net force. You will start, I think this is called the head to tail rule. You'll start from where both the tails of the original yellow arrows meet, and you'll take your scale and your pencil and you will draw the arrow to where the two heads of the blue arrows meet. So you'll take your arrow from the tail of the yellow arrows and you'll take it to the heads of the blue arrows. Now it's very important that you don't do this the opposite way, because like I said, we're talking about vectors and vector direction is important. Because if you did this in the opposite way, the direction would be, this would be the direction. But the direction of the net force is actually this. So it's very important you take it from the tails to the heads. Now what you need to do is you need to measure this arrow. Now since I've done this before, I know that this arrow will measure around 8.6 centimeter. What you need to do now is go back to your scale and you'll see that, okay, so 1 centimeter is 1 Newton. This would mean, if you cross multiply, your scale is a bit more complicated, this would mean that 8.6 centimeter is equals to 8.6 newtons. So there you have your magnitude and units for your net force. But like I said before, you need to have a direction too, because this is vectors that we're talking about. What would the direction be? Now there's a lot of ways to talk about direction, but I will talk in terms of north and east. This is north, this is east. So I'll say that the net force acting on this box is 8.6 Newton north of east. This is east, and the force is north of east. So it's acting, there's 8.6 Newton north of east. Now one last thing that I want to mention is graphical addition with reference to the Pythagoras theorem. This is important because it usually pops up in P1, and for those that have not attempted this question before, it gets kind of confusing. Alright, so look over here. The way we figured out the net force was by measuring this purple line. We used the scale method and we measured it physically. But there's also a mathematical way of figuring out that usually comes in P1 because P1 is MCQ and they can't ask you to draw it. So the mathematical way is by using the Pythagoras theorem. Like I said, this is a right angle triangle, which would mean that this purple line, which represents your net force, is your hypotenuse. And, oh, I am so sorry. This is supposed to be 5 newtons and this is supposed to be 7 newtons. I'm so sorry for that. Alright, so your 5 newtons will be your perpendicular and your base will be 7 newtons. Now that you have these three values, you need to find, you have two values, and you need to find the hypotenuse, which is the net force, by the way. You can easily apply this theorem. You can find the net force and you won't even have to use a scale to convert it. However, in your actual exams, they don't give you the entire rectangle. They just give you this triangle. And this is problematic because I'll come to that. They'll give you the direction of the original forces. They'll say this was the direction, this was 7 newtons, this was 5 newtons. Now you can easily figure out the magnitude of the net force using the Pythagoras theorem. You'll be like, okay, 5 squared plus 7 squared is equals to hypotenuse squared, right? But the problem is that you know the magnitude, you know the unit, you don't know the direction. What a lot of people make a mistake in is that they assume that the direction is going to be this way, that the net force will be this way. This is completely wrong. Why? Because like I said before, your net force starts, the arrow for your net force starts from where the two tails meet and it goes to where the two heads meet. Now look over here. It's starting from this point. If I were to draw the entire rectangle like this, you have 5 newtons here and I redraw the 5 newtons here. Is this arrow, the net force arrow, starting from where the two tails meet? It's not. This is where the two tails meet. which means that the net force, the direction of the net force is not this. The direction of the net force will be this. This, I believe, is northeast, and this, I believe, is northwest. So that's two completely opposite directions. So make sure you're not tricked by this. Make sure that you're careful and make sure that you draw the entire rectangle so that you can make sure that you have the direction correctly. And again, you can still figure out the proper magnitude if you don't draw this rectangle thing. You will still have the proper magnitude, but you won't have the proper direction. So this was it for this video. I hope it cleared some concepts out. If you're still confused, I'll be more than happy to answer questions in the comments. And stay tuned for more videos. Thank you.